In this video, we will look at activity 2A, which is about preparing solutions. So our first problem says, what mass of table sugar, and it tells us that table sugar is C12H22O11, is needed to prepare 0.875 liters of 0.75 molar solution. And so, in order to solve this problem, we need to understand what molarity means, what this capital M means. And this big M molar means moles per liter. And so this 0.750 molar, 0.750 molar, means that there are 0.750 moles of this substance in every 1 liter of solution. And so once we understand what molarity is, we know that we can use this as a conversion factor to figure out how many moles are necessary to prepare this many liters of solution. And so we can start out by taking our number of liters of solution. We need 0.875 liters. And then if we take our molarity, our conversion factor, we can set our conversion factor up so that our liters will cancel and we'll be left with moles. So we want liters to cancel, we want that to go on bottom, and we want to figure out how many moles will be required. So we use our conversion factor in the order that is shown here, with 0.750 moles on top and then 1 liter on bottom. So we need 0.875 liters times 0.75 moles over 1 liter, and that will tell us how many moles of our substance we need. So when you're reading problems, there are some words that can clue you in to what mathematical operation to do. So the word of in math typically means multiply, and if you notice, we did 0.875 multiplied by 0.75 molar. Moles per liter. And so this of is a clue word that tells us that we're probably going to be multiplying 0.875 times 0.750. And indeed, that's what we did. So let's go ahead and figure out how many moles this is. 0.875 times 0.75 gives us 0.65625 moles. And of course, I don't want to know the number of moles because I can't actually weigh out a number of moles. There's no way to measure moles. We don't have a scale that does that or an instrument that does that. So we need to figure out how many grams of table sugar we need. And now that we have a number of moles, it's relatively easy to convert between moles and grams. We just need to find our molar mass of this substance. And so I have 12 carbons. I have 22 hydrogens, and I have 11 oxygens. My mass of carbon is 12.011. You can find that on the periodic table. Hydrogen is approximately 1 gram per mole, and oxygen is 16. So I just need to figure out the total molar mass of C12H22O11. I'll figure out each piece and add them together. So 12 times 12.011. Gives me 144.132. 22 times 1, of course, gives me 22. And 11 times 16 gives me 176. Now I'm just going to add all three of these numbers together. Plus 22 plus 176. And that gives me 342.132 grams per mole for our substance here. So then we're just going to use this to convert between moles and grams. So I'm going to put 342.132 next to grams. 0.132, I didn't leave myself quite enough room. And then I'm going to put 1 mole on bottom because that is the number of grams in 1 mole of C12H22O11. Now all we need to do is multiply this out. My moles will cancel and I'll be left just with the number of grams of C12H22O11 that I will need. So 342.132 times 0.65625. And that gives me 224.524 grams. And of course I'm going to look at the significant figures in my problem. I have 3 sig figs here, And I also have 3 sig figs here, so my answer should have 3 as well. So I'm going to round this to approximately 220, so make it round up, 225 grams of C12H22O11. So that is how much table sugar we would need to prepare 0.875 liters with a concentration of 0.750 molar. On to number 2. Number 2, I'm going to move the page up just a little bit here, says how many grams of salt are needed to prepare 250 milliliters of 0.5 molar salt, and here it actually specifies that it's NaCl, salt water. And it's good that it specifies NaCl because there are different types of salts. Sodium chloride is table salt, it's what you put on your food, but there are many, many other salts, meaning an ionic solid that we use in chemistry class, so it's important that it's specified here. So once again, we're given an amount of solution and we're given our molarity, so the 0.5 molar means that in every 1 liter of solution we want to have 0.5 moles of NaCl. So we can start off by figuring out how many moles of NaCl are needed, and then we can convert our moles of NaCl into grams of NaCl. Now here, you might notice that the volume is not given in liters, it's given in milliliters, and to be able to use our conversion factor here, we need a number of liters. So I'm going to start out by converting 250 milliliters to liters. Milliliters to liters, there are 1,000 milliliters in 1 liter. So I have, move my decimal point 3 times, 0.250 liters of solution that I want. And now I can take this value, use my conversion factor to convert it into moles. So once again, liters is going to go on bottom, and then moles is going to go on top. And then I have 1 liter and 0.5 moles. Liters will cancel out, and I'll just be left with moles of NaCl. So I'm going to do 0.250 times 0.5, which gives me 0.125 moles of NaCl. Now I just need to convert my moles into grams, and then I'll know how much I need, and I'll be able to actually measure that out using a balance. So NaCl, if you add up the molar mass of NaCl of sodium plus chlorine, it's 58.45. So 58.45 grams per mole for NaCl. And so I need my moles to go on bottom, grams to go on top, so I'm going to put my 58.45 next to my grams, and I'm going to put 1 mole on bottom. So then my moles will cancel, and I'll just be left with the number of grams of NaCl. So I'm going to do 0.125 and then multiply by the molar mass. And that gives me 7.30625, but I'm going to round to appropriate sig figs here. I only have 1 significant figure here, and then I have 2 significant figures here, so I'm of course going to round to 1. So this is approximately 7 grams of NaCl. Box that answer in. This next problem says how many grams of glycerin, C3H8O3, are needed to make 100 milliliters of 2.5 molar solution. And you might notice this decimal point after 100 indicating that all 3 digits are significant here. But we're not going to need to worry about that till the answer. So we have 100 milliliters of that clue word that means multiply, 2.5 molar solution. That 2.5 of course means that there are 2.5 moles in every 1 liter of solution. And so we once again have milliliters, and we know we need to convert that first 2 liters, so then we can use our molarity as an effective conversion factor. So we're going to take 100 milliliters, and we'll convert milliliters to liters by dividing by 1,000. So 100, move our decimal point 3 times, so we get 0.1 liters of solution. And then now that we have liters, we can convert to how many moles this solution needs to contain using our molarity. So liters goes on bottom, we want moles to go on top, so we put 2.5 moles per every 1 liter. So let's see, 0.1, move that so we can see it a little better hopefully, move this down a little bit, let's see, 0.1 times 2.5, which gives us 0.25 moles. And now, of course, we need to figure out how many grams we need because we don't have any sort of device that can measure out moles for us. And so to measure this out, we need a number of grams. So we're going to convert moles to grams using the molar mass of C3H8O3, which we need to calculate. C3H8O3, we have 3 carbons, 8 hydrogens, and 3 oxygens. Carbon is 12.011, hydrogen is 1, and oxygen is 16. So we add all this up, 12.011 times 3. We get 36.033 plus 8 plus 16 times 3, which is 48. So we add all that up. We get 92.033 grams per mole. So our number of grams is going to go next to grams, 92.033, and then per 1 mole. So now we just need to take 92.033 and multiply by 0.25. That gives us 23.00825 grams, and we need to round to appropriate sig figs. So we already said we had 3 sig figs here, then we have 2 sig figs down here, so we're going to round to 2, which would just be approximately 23 grams of glycerin. Box that answer in. Our next question, let me move the page up for you a little bit, says how many grams of table salt must be added to 567 milliliters of water to prepare a solution that is 8% NaCl by mass. So this problem is kind of interesting because we know that to figure out percent by mass, we need the mass of whatever we're talking about. So in this case, NaCl, we need mass of NaCl over the total mass. And our total mass is made up of both the mass of the NaCl and also the mass of the water, mass of H2O. So we can figure out one of these things from the problem. It tells us that we have 567 milliliters of water, and we know that for water, 1 milliliter is the same thing as 1 gram. So we know that we have 567 grams of water. So 567 grams of water. But we don't know what the mass of NaCl is. That's what we're trying to find. We're trying to find grams of table salt. So we don't know the mass of NaCl, which is in 2 places in our problem. And so in math, when we don't know something, we substitute in a variable. So we are going to substitute in the variable x in both places that we need to have the mass of NaCl. So we're just saying that x equals the mass of NaCl, and we will solve for x and then figure out what the mass of NaCl is. So this whole thing, the mass of NaCl divided by the mass of NaCl plus the mass of H2O, should be equal to our percent by mass, which is 8%. But in order to have this equal to 8%, we need to write 8% as a decimal. So we're going to move the decimal back 2 times. 8% is the same thing as 0.08. So this whole thing is going to be equal to 0.08. So let's substitute in some values. So we have 0.08 is going to be equal to mass of NaCl, which we said we're going to put in x, divided by mass of NaCl, so x, plus the mass of H2O, which we know to be 567 grams. So we have 0.08 equals x over x plus 567. So now we have to do a little bit of algebra. So in order to get, the first thing we want to take care of is this thing in the denominator. In algebra, we don't like to leave things in the denominator, and so to get rid of something in the denominator, we multiply by whatever's in the denominator on both sides. So I'm going to multiply by x plus 567 on one side, x plus 567 on the other side. And so these cancel out, and we're left with x plus 567 times 0.08 equals x. Now, on our left-hand side, we have something outside the parentheses and then two things in the parentheses. So I'm going to go ahead and distribute this out. So I get 0.08x plus 567 times 0.08, 0.08 times 567, which gives me 45.36, and that is still equal to x. Next, what we want to do is combine our like terms. So we have x's on the left side and we have x's on the right hand side. And since there's no coefficient in front of x, we know that there's only one x over here. So I'm going to fill in that coefficient now. Okay, so we need to subtract the 0.08x on both sides. So these ones cancel out, and we're left with 45.36 equals 1x minus 0.08x. 1 minus 0.08 is, so we have 0.92x. And then last, we just need to divide by 0.92. So our x is going to be equal to 45.36 divided by 0.92, which gives us 49.304. And so coming back to figure out our unit, we know that x was equal to the mass of NaCl. So this is a number of grams. So 49.304 grams. And of course we want to round to appropriate significant figures. So we have 3 significant figures up here, and then we're not going to look at the significant figures given in the percent by mass. We don't look at percentages when looking at significant figures. So we're just going to keep the 3 significant figures in our volume. So we'll round this to approximately 49.3 grams of NaCl. Box that answer in. Of course, make sure you can see it. Move it over for just a second. Our last problem says how many grams of potassium nitrate must be added to 1.2 liters of water to prepare a solution that is 14% NaCl. Whoops, I don't think that's supposed to say NaCl. I believe that's supposed to say potassium nitrate. To prepare a solution that's 14% potassium nitrate by mass. And so here we are going to use the same strategy that we used in number 4. We need to figure out how many grams of potassium nitrate, so a mass of potassium nitrate, KNO3, divided by the mass of the total solution, mass of KNO3, plus the mass of H2O, and we need this whole thing, this whole proportion, to be equal to 14%, or 0.14 as a decimal number. And we are looking for the mass of potassium nitrate, so these two things we don't know, but they happen to be the same number, so we can substitute in the variable x. And then of course we know the mass of water from the volume of water. But we need to convert this to milliliters first. So 1.2 liters, liters to milliliters, so we're multiplying by 1,000. So we get 1200 milliliters, which we know is the same as 1200 grams for water. So let's set this up as an algebra problem. We have 0.14 equals x over x plus 1200. Now we just need to solve our algebra problem. We're going to multiply by x plus 1200 on both sides to get things out of the denominator. So then these cancel out. We end up with x plus 1200 times 0.14 equals x. Then we're going to distribute. So we get 0.14x plus 1200 times 0.14, which is 168, equals x. We know that this, since there's no coefficient, there is a 1 that's implied, so 1x. So we're going to combine our like terms and subtract 0.14x on both sides. So then those cancel out. We get 168 equals 1 minus 0.14, 0.86x. Then finally we divide by 0.86 on both sides, and we get x equals 168 divided by 0.86, which is 195.3488. We know we need to round to appropriate significant figures, so looking back at the problem, we have 1.2, which has 3 sig figs, and we remember we're not going to look at our percentage here, we're just going to look at the volume. So we round to 3 sig figs, so we're going to round this to approximately 195 grams of KNO3.